In this lesson, we're going to talk about simplifying square roots by applying a couple properties and showing you a few examples of those properties in action. Before we actually show you the properties, I just want to discuss some vocabulary with you briefly. If you draw that square root sign, we really call that a radical sign. So that is our radical sign. Any number that you write inside of the radical, so if I have the number 7 for instance inside, that number is called the radicand. So the radicand is just a fancy way of saying the numbers inside of a radical. Now if we put the whole thing together, that expression is called a radical. Alright, now two properties that we're going to use are the following. So here they are. Now when we talk about these properties, we're assuming that the numbers inside the radicands are positive numbers. So A is bigger than 0 and B is bigger than 0. So these numbers cannot be 0, they cannot be negative. Otherwise these properties don't necessarily apply. The first one is the product property, which says the following. If I have the square root of a product, A times B, that's the same as the square root of A times the square root of B. A nice example that we can apply here is, if I have the square root of 36, let's say, we know that the square root of 36 really is just 6, right? But just for illustration purposes, let's say we want to split this up. 36 is the same as 4 times 9, and if I apply the product property, that's saying I can square root 4 and then multiply it to the square root of 9. Now the square root of 4 is the number 2, the square root of 9 is the number 3, and if we multiply those, we get 6. So they are equivalent. We can apply the product property. A very important feature of the product property is the following, and really this is the definition of a square root. If I have the square root of x times x, that's the same as the square root of x times the square root of x. We would just get the radicand x out. So anytime you multiply two of the same radicals together with the same radicand, you get just the radicand out. So we're going to be using that very, very often in the simplifying process. The other property is the quotient property. And what that one is saying is the following. If you have a quotient of A over B inside of a radical sign, you can square root the top over the square root of the bottom. So you can square root the numerator and denominator separately. Let's do an example together where we're going to have a lot of different sub-examples inside of example, and we're simplifying some radicals based on these two properties. The more examples you kind of see and experiment with, the better off you'll be. So I'm going to kind of go in detail on a few of the first ones and then kind of go a little bit faster as we work through it. Let's say I have the radical, the square root of 24. Now, I'm going to do it kind of the long and drawn out way at first and then show you a couple shortcuts, which is probably how I would do it. But what you could do is break 24 down into its prime factorization. So 24 I know is the same as, let's say, 4 times 6. Somebody else might have thought 12 times 2, and that's fine. But keep breaking it down until you can't break the numbers down anymore, so you're in your prime factors. So I get to the point where I'm stuck with 2 times 2 times 2 times 3. If you multiply all those factors together, you will get 24. So this is the same as, alright, the square root of 2 times 2 times 2 times a 3. Well, I am going to now apply the product property, and I can do square root of 2 times the square root of 2 times the square root of 2 times the square root of 3. That's supposed to be a times sign there. Now, I know that the square root of 2 times the square root of 2 is really the number 2. Recall, if I have the square root of A times the square root of A, we just get A. So that's what I'm kind of applying here. And then I'm left with these two oddballs that I can't combine to pull a 2 or 3 out. So I'm left with the square root of 2 times 3, which is the same as the square root of 6. So I'm stuck with 2 times the square root of 6, and this is simplified. The idea is to pull out perfect square factors. Now, what I would do as a shortcut, actually there's two possible shortcuts. The first one, if you are breaking down the square root of 24, and as soon as you break it down, if you can recognize a perfect square factor like the number 4 is a perfect square, I would stop and just rewrite this as the square root of 4 times the square root of 6. Because I know what the square root of 4 is. That number is 2, and then I'm left with the square root of 6, and I am done. Another shortcut would have been to do this. If I have the square root of 24, let's just say you said 12 times 2, or 2 times 12, and then you broke 12 into 2 times 6, and then 6 is a 2 times 3. Let's just say you happen to do it that way, and you wrote all the same factors out, 2 times 2 times 2 times 3. A lot of students will circle any pairs of factors and pull them out front. So if I have a pair of 2's, I can pull 1 2 out in front, leaving behind a 2 times a 3 inside, and I have 2 root 6. So there you have 3 different ways of essentially getting the same simplification of the square root of 24. Let's do another one in maybe a short fashion. Let's go with, let's say this is b. Let's simplify the square root of 40. If I'm going to simplify the square root of 40, I'm looking for the shortest way possible, and I'm looking for perfect square factors, numbers that I know I can square root very easily. And I know I can break 40 into 4 times 10, 4 being one of those perfect square numbers. So right away, what if I just wrote square root of 4 times square root of 10, and I know square root of 4 is really just the number 2. 10 breaks down into a 2 times a 5, so there's no common factors inside of the square root of 10, so there's nothing else to pull out. So I'm left with square root of 10. So 2 root 10 is my simplification. Now there's an easy way to check actually if you have a calculator, any calculator, scientific or graphing, to make sure that you've simplified these correctly. What I would do if I were to check the square root of 40 and 2 square roots of 10 to make sure they were equivalent is I can, in my calculator, type in, let's turn it on first here, if I type in the square root of 40 and just see what that is, I get about 6.32, and then I'm going to type in 2 square roots of 10 and see what I get there. Now if these expressions are equivalent, I should get the same answer, and I do. So I know for sure I've simplified it correctly. So that's just something nice you can do to quick check that you're doing all these problems correctly. Let's do one more example of applying the product property before we go to the quotient property. If I have the square root of 6 times the square root of 15, I can kind of use the product property in a reverse order and go ahead and combine 6 times 15 under the same radical sign. Now what I might do from here is break these numbers down into their prime factors, and 6 I know is 2 times a 3. 15 I know is 3 times a 5. Now check this out. These are the prime factors of the product, and if I put them all together I have a 2 times a 3 times a 3 times a 5. Anytime I see a pair of the same factors together, I'm going to pull one out. So I have 3 out in front, and I'm left with a 2 and a 5 inside, which multiply to make 10. So 3 radical 10 would be my answer. Another way of doing this, just to show you, there's multiple ways to skin the cat, so to speak. Once you have the square root of 6 times 15 together, I could have went this route and multiplied them, and 6 times 15 is 90, right? From there you might have said, alright, 90 I know is just 9 times 10, and there's a perfect square, so I would just stop there maybe and do, alright, this is the square root of 9 times the square root of 10. Square root of 9 I know is 3. Square root of 10 doesn't break down into any other perfect square factor, so whoop, I'm done. Get the same answer 2 different ways. So hopefully you find a style that works for you to build your confidence with this. Let's do an example here of the quotient property. If I have the square root of 7 7/16. What the quotient property says is I can square root the numerator and I can square root the denominator separately. Square root of 7 cannot be broken down. However, the square root of 16 happens to be a perfect square number of 4. So this is just the square root of 7 over 4, and I'm done. There's nothing more for me to do. Let's do another one on here, one that's a little bit more fun. I have the square root of 7 over 2. I'm going to do the same thing I just did. I'm going to square root the numerator and I'm going to square root the denominator separately. Now, you can't simplify the square root of 7. You can't break that number down, and 2 also can't be broken down. But this is bad news if we are left with a radical in the denominator. I wish I didn't highlight it right over. I didn't think it was going to go that thick. Let me undo that. I can't have a radical stuck in the denominator. So what you do to undo having a radical in the denominator is we rationalize the denominator, meaning we're going to make it into a rational number by multiplying it by the same radical that you see in the denominator. So because I have a radical 2, I'm going to try to get rid of it by multiplying by another radical 2 to the top and bottom, because after all, this entire fraction, radical 2 over radical 2, is really the number 1 in disguise. So I'm not changing the value of this fraction because I'm multiplying it by 1. But it changes the appearance. I'm going to have radical 7 times radical 2. That's the square root of 7 times 2, or 14, over radical 2 times radical 2 is the square root of 4, or just the number 2. And now this doesn't have a square root in the denominator anymore, so this one is simplified. Kind of tricky there. Now also, don't do this. Don't do like what some students do and be like, ooh, this is just the square root of 7, right? Because I can divide 14 by 2. 2 and 14 are not like numbers. It's really the square root of 14 divided by just 2. You'd have to apply the square root to 14 before you could divide it by 2. Let's do one last example, one that's kind of nasty. So here we go. I forgot what we were on. Is this example F? Let's try this guy. Let's go square root of 18 over 11 times square root of, let's do 4/3. This is kind of a cool one because we have the best of both worlds. We have a little quotient going on, and we also have a product property involved as well. And so this is what I would do. I would put all of these numbers, or these rational numbers, inside the same radical sign. So I have 18 over 11 times 4/3, right? Now, what I might try to do here first is see if I can simplify inside of the radical. So I'm going to simplify the radicand if I can. So I know that 18 is the same as, what, 6 times 3, and I'm multiplying that to 4. Really, when you multiply fractions, you're multiplying numerators to numerators and denominators to denominators. So 11 times 3 I can't split up, but do you see how you have common factors of 3 in the top and the bottom? I can cancel those out. So I'm going to do that. That leaves me with the square root of 24 over 11, which maybe wasn't the greatest idea to do, but I'm going to do that. And now apply the quotient property and take the square root of the top over the square root of the bottom. Now, I think we can break 24 down. Didn't we do that in the first example? Wasn't 24 the same as 6 times 4, isn't it? So because I can rewrite that as the square root, let me rewrite it this way, the square root of 4 times the square root of 6 over the square root of 11. Square root of 4 really being the number 2, I have 2 radical 6 over the square root of 11. Now this is very close to being completed. However, I can't have this radical in the bottom. So what I have to do is rationalize by multiplying the numerator and denominator by that radical. If I do, I'm going to combine the radicals. These are like numbers together. So I'm going to have 2 out in front, and the square root of 6 times 11 over 11, root 11 times root 11 is just going to be the number 11. So one last step here, I'd end up with 2 radical, 6 times 11 is 66, over 11. I'm not going to try to divide the 11 and the 66 because 66 is in the radical and 11 is not. 2 and 11 can't reduce because they have no common factors. So we are finished here. I hope you learned a little something about how to simplify radicals or square roots in this video. Thanks for watching.